All right, guys, Mr. Antonucci here, and we're continuing on with section 8.3. And this time we're going to do the same thing with the disk method, except we're going to revolve the region about the y-axis. And the same process is going to happen here as we use to figure out the volume of a solid generated by revolving the region about the x-axis. Except the only thing that's a little bit different here is that the function has to be in terms of y, and instead of making a vertical strip, you're making a horizontal strip. So the thickness of the strip is considered delta y, and the radius is the function of y. And so what it ends up boiling down to, once you get the Riemann sum, take the limit as the number of strips approaches infinity, you have pi times the integral c to d of g of y squared dy. So it ends up being the same process. You just have to identify it in terms of y. And so here we have a region bounded by the graph of y equals x cubed. The y-axis, the lines y equals 1, x equals 8. Now here's when we try to get the volume of this, we know that we have to rotate it about the y-axis like this. So this region here. You see already, if you rotate it like around the y-axis and you just picture that shape being, that region being rotated, you automatically get a horizontal like circle. Also, if you tried to make a vertical strip here, you'd run into some issues because the top and bottom of the vertical strip is going to be different as you move along. But if you do a horizontal strip, that's quite easily rotated because the one boundary is the y-axis and the other boundary is the curve. Now here's the thing. This function is given in terms of x, so like y equals x cubed. So oftentimes you'll just have to solve that as x equals the cube root of y, or y to the 1/3. Okay? So if we take a representative strip and rotate it around, the radius in terms of y is equal to y to the 1/3. Then the volume is going to be pi times the integral of y to the 1/3 squared dy. Now, when we get the limits, be careful here. We're not going from 0 to 2. That would be in terms of the x-axis. Since we're integrating with respect to y, the limits have to be in terms of the y boundaries of the region. So namely y equals 1 and y equals 8. So we're going to go from 1 to 8. All right, so simplify this up. Integral from 1 to 8 of y to the 2/3 dy. And this would be pi. The antiderivative would be 5/3 times 3/5. Plugging in 1 and 8 and subtract. So when we plug those values in, we're going to get 3 pi over 5 times. You plug 8 in. The 5/3 power is like taking the cube root of something and then raising it to the 5th power, or raising it to the 5th power and then taking the cube root of it. Well, cube root of 8 is 2, and 2 to the 5th is 32. And then when you plug in 1, you just get 1 there. So you end up with 31 times the 3 pi over 5, which is going to give us 93 fifths pi. And it would be cubic units, whatever those would be for that situation. They didn't give us the units. So here's one more example for this one. We're going to use the disk method again. And here we have the region bounded by natural log x, the line y equals 2, both axes, and we're revolving it about the y-axis. So we know we're going to put our crank on the y-axis and rotate it. And so since our axis of revolution is vertical, the strips typically, with the disk method and also with the washer method that we'll learn in another video, they're going to be perpendicular to the axis of rotation. So in other words, since you have a vertical axis of rotation, your strip is going to be taken horizontally. If you take a horizontal strip, then it's thick. The thickness of that strip is dy. Okay, so we have a circle there. And the volume function in this situation is given by this graph, which is natural log of x. But because y equals natural log of x is in terms of x, we need to solve this for x to get it in terms of y. So if we exponentiate both sides, we get x equals e to the y. So the radius function in terms of y is going to be e to the y. And the volume is pi times the integral of e to the y squared dy. And again, the limits go in terms of the y-axis. So you go from 0 up to 2, and that gives you your interval. So we have pi integral 0 to 2 of e to the y, or e to the 2y dy. So e to the 2y's antiderivative would be 1/2 e to the 2y times the pi. Plug in 0 into and subtract. So you'd have pi over 2 times, if you plug in 2, you get e to the 4th. And if you plug in 0, you get e to the 0, which is 1. Now it's okay to leave your answer like that in terms of e, but you could pump it into Desmos and get the decimal value, which would be approximately 84.192. All right. So that's it for this one, guys. Hope that was helpful. Reach out if you have any questions. Take care.